Hello guys, Ganesh here. So today's topic, the draft angle. Okay, let's get out of this PPT. So see, imagine you are having one plastic box. So those may be, wait, let me take in one snip. Okay, so those are, if you see a plastic box, so some boxes may having the straight walls. Okay, this may be base and these are the walls. Okay, some boxes are having the straight walls, or some boxes are having this slanted walls. Okay, so in this video we are not going to discussing about this straight walls, because those things can be manufactured within a different way, so that is called blow molding process. Okay, so which is not on our syllabus. Okay, let's close it off and let's talk about the slanted walled plastic parts. Okay, generally the plastic parts which are having the which needs to have the slanted faces, so that is draft faces, those can be achieved by injection molding process. Okay, so last video I already explained you about what is injection molding, right? So let's arrange things. Okay, so in the last video we have seen a core will be there like this. Sorry, like this core will be there and a cavity will be there. Okay, wait, I don't want to take more time on this. Okay, let's complete it quickly. So this is the cavity, this is a core, right? So what will you having in injection molding? You will be having one a gap like thing. So in that gap you will be pouring your molten plastic material, and after solidification you will be taking out the part, right? So that is what will happens in the injection molding, right? So now imagine these walls are straight one. What will happens? So after solidification, since it is a plastic part, it will tries to stick to these walls, right? So in order to, after solidification, if we want to take it out injection purpose, so if it is stick to these straight walls, it may takes a 10 seconds or 20 seconds of time to take out this, right? So in order to take out this, in order to reduce that ejection time, so we are introducing this draft angle. Okay, so basically what a draft angle will do is, so since you are having the slanted edges, so even though the plastic material after solidification it is stick to the walls of core, it can be easily take out from this. So that is the purpose of draft angle. And you see, someone will do a draft angle like this. See, this my let's say we're doing one part like this. Okay, okay, I can achieve this, but imagine if you're having a part like this, can you even achieve this? Yeah, you can achieve this, but talking about the draft angle, so you my core will be acting on this direction, right? So in this case my core cannot be fit into this cavity properly, and and after the core also, so if the part is already sitting in this cavity, means it will takes it won't possible to take out from this, right? So this is why the draft angle is important. And this phase, So why we are providing draft angle? In order to facilitate the manufacturing process easy. In order to facilitate the ejection process easy in a manufacturing process, we are providing the draft faces. Okay. Okay, this is about the draft analysis, and of course, and if you are making one part in software, you have done modeling everything. Okay, the part is quite good and looking aesthetically very good and very good, but what will happen, it may fails it cannot be able to manufacture because of that because of that poor draft angle. Okay, now let's talk about the question that you have seen. So what if it is 3 degree to 10 degree? So why these values? See, if it is more than 10 degrees, my part will looks like this. Okay, so what will happen? See, let me explain you with an example. Let's take a one paper, a plain paper. If you put a paper like this and if you add any weight, what will happen? It will easily weather out, right? So but what will happens if you fold a paper like this, a zigzag manner, and if you put some weight here, so what will happen? Some more or less it can able to withstand, right? So that is the purpose of here also. If it is more than 10 degrees the draft angle, so it will losing its tendency of giving this draft angle, it losing its strength. Okay, so what will happen if it is less than 3 degree? So what will happen? So 3 degree, the between 3 to 10 degree, which is okay to manufacture, but less than 3 degree means 0 to 3 degree. So we are having the parts having the draft angle of 0 to 3 degrees, but what will happen, the cost effectiveness. So in order to achieve a 1 degree draft surface draft phase, you will have to spend more. So one or two parts the spending extra means that won't happen, that won't cause anything. But imagine if you are making 1k parts or 200k parts, so what will happen? So the cost will drastically very high, right? So that's why you should keep in your mind whenever you're making the draft plastic part, you have to keep the draft angle 3 degrees to 10 degrees. What happens less than 3 degree, it will cost more, and what happens it's more than 10 degree, so it's losing its stiffness rigidity, or stiffness or rigidity, right? So this is the purpose of giving the draft angle as 3 to 10 degrees, guys. And okay, now you have done a part, so you want to check it. So you cannot give to a production member and ask you to produce it, right? So since you are using a software, you should check the draft phases and the draft analysis. So if something is being mistake in the draft analysis, you should clear the mistake right from your system also. Okay, or else what will happen is the operator, the production member will produce that part, and while the production he found that it is not possible. Okay, so being a design engineer, it is your responsibility to make the parts which can be easily manufacturable, and you cannot make a part which cannot be manufactured. So that is about draft angle, guys. Hope you guys clear about it. Okay, now let's see about, so what are the features that are there in CATIA for making the draft analysis. Okay, let me open the software, wait for a few seconds. So you are having the draft analysis in NXCAD also. Okay, but now we are not seeing we are not seeing how can we done draft analysis in the next. We'll see only the CAD. Okay, so initially what will happens the class A, so we on which you have to work, right? That is given by uh, the some other department colleagues. Okay, after that you have to open it in the CAD app. Okay, wait. I'm having. Okay. Okay, I forgot about where I have saved that files. Yeah, cat. New challenges. Yeah, submissions. Okay, let's take one example. Okay, on step file. Let me open this. Okay, the part, the class A surface is looks like this. Okay, initially you will be not even seeing what is the functional requirement of this part. So this is how the class A will looks like. Okay, after that you can see the term that I have explained, the draft angle. So those are the faces that you can see with a different color. Those are the draft angle faces. Okay, so in order to check the class A surface is itself is done in a way that it should match the manufacturing feasibility. Okay, so if you want to check how much the draft angle is this, so that is what you can say it as a draft analysis. Okay, so what will happen, the class A surface will given like this. You have to do class A draft analysis. So for that you need to create an axis, and from that axis uh, see okay, from that axis you will be taking that axis as a reference for calculating the angle faces. So let's do that. So what I do, I simply take one point at this mid of this curve, middle point, click on OK. Now what I do, I'm taking one line, okay, and point and direction. Point is already selected. Direction, I'm choosing the Z component. That is what you can see in from the compass. Okay, after that let's drag like this, click on OK. Now see, this is my draft. This can be act as my draft. Okay, more precisely we can call it as a tooling axis. So what does it mean by, so when I specifying the draft tooling axis this, so if my core and cavity is done like this, my core will be on bottom side, my cavity will be on top side. So when I specifying the this line as my tooling direction, so this is the point where I am having the uh, opening face in the cavity in this direction for pouring the molten plastic resin inside the cavity. So this is what the tooling direction means. So next video will be the tooling direction, that will be our next topic. So I'll be explaining completely about tooling direction. How can we create it? How can we okay, how can we create? We can see in the next video itself. Okay, now let's talk about the draft analysis. So in order to do a draft analysis, you should have a axis like this. So most probably the axis will be, has to be definitely your tooling axis. Okay, What does it means? So when your tooling axis is like this, okay, so right now the tooling axis is not correct. Okay, what does it means? When you are having a tool direction like this, tool axis like this, so your molten plastic material will flow in this direction. So in this way, what will happen? The molten plastic material will reach the every single corner of the mold part very easily. So imagine if you are having the draft angle like this, what will happen? So maybe this region will won't cover exactly by the molten plastic material, right? So this is why you should keep in mind that draft analysis should be done before making even the class B surface. Okay, now let's talk about, there is a feature called draft analysis, feature draft analysis, which is very simple than you think. Okay, so every time it is asked about change the view style. So what I do, I just go to this view style and click on this question mark and make sure it is material and all edges and all points are ticked out. Click on OK. Now it is okay. Now what you do, see, this is a small window. So in order to do draft analysis, now here you can see the compass symbol, right? So click on that compass. What you will see, my compass has came. I can pan it by selecting the origin point like this. So select this or select this compass. What will happen, you will be having the compass. So place it on your tooling axis. Okay, after that you can, if you want, you can lock it, so there is no problem. And after that, you, if you select this, what will happen, the object is seems in a green color. Why? See, this is a window that will explain you. So see, if I am changing the value to 5 degrees, okay, if I'm changing the value to 2 degrees, still it will appear in, okay, if I change the value to 1 degree, yeah, you can see that, right? So what does it means? So those are appearing in the green color are the draft faces having the draft angle of 0 to 1 degree. Okay, so but earlier you have seen the blue phase also. So what does it means? Those are having the less than 3 degree will be appearing in blue color. Okay, let's change it to 3 degrees. I told you all the plastic products should be designed with minimum 3 degrees of draft angle, right? So this is a part having the 3 degrees of draftness, but what will here you can see this face is not 3 degrees now. Why? Because you are not selected the tooling axis in proper way. So that is why it is looking like this. And generally what will happen, the class A surface will be given, right? So from the class A itself you are seeing the, you are developing the tooling axis. So in the simple words, what can I say, the tooling axis should cover every single face properly. So in this way it is covering this phase, draft phase, but in a very, when compared to like this, which is not uh, covering this draft phase, right? So what I do, I will have to choose another line. So how can I choose another line? So which is very simple. Let's create an, okay, let's insert an axis system, insert axis system at this point, click on OK. Now what I do, click on the position sketch, select the relevant plane, okay, is okay, and choose the point and choose the axis. This way, click on OK. Okay, now what I do, I'll just take one line. Similarly, what I have done, set this point and this line, right click coincidence, and select this line, and choose one draft angle of, for example, 5 I take. Okay, now exit. Now initially you have created a line, later you have created a sketch. Okay, with a line you are having some issue with the draft analysis. Okay, let's hide this. So now uh, yeah let's take this line, which is a sketch, and choose a draft analysis. Okay, leave. So you click on this feature draft analysis and choose the compass. Place the compass on your axis and lock it and select the body. Now see, even though it is 3 degrees, it is showing in green color, right? So whenever the parts that you are doing, whatever the part you are doing from the class A, it should be appear like this. All faces must be less than 3 degrees of draft angle. So that's it, guys. That's up to this video. Hope you learned good things in this video. So if you learned this kind of videos, in the next video is about tooling axis. Okay, now I just created this line with a sketch, and we even with the line and points also. So next video we will be seeing the proper procedure for making the draft angle. Okay, so until then, bye guys. Keep touching our channel for getting the more updates like this.